Hello Matrix, welcome to your first lesson of AP for this year. So what we're going to be doing for the first week is we're going to revise normal distribution to the binomial approximation. So for this first lesson, I'm going to do, I think, 6 examples from another textbook. One of them I seem to recall that we did do in class at the end of when we did normal distribution last year. So that might be familiar, but the rest I think are new to you, and it does serve as a good revision of the normal distribution. Okay, so the first lesson is just routine questions, the little bit more easier questions, and in the second lesson is the more problem-solving questions. So what I suggest that you do is, for this lesson, you need to have your Z table with you, your standard normal distribution table. Always have that with you when you're doing normal distribution, and if you do feel that you need a little bit of revision of the concepts and of the actual conceptual understanding, then now's a good time to pause the video and go to the stream channel on Microsoft Teams. So in other words, you go to General, then at the top right, there's a video stream tab. If you click that, you'll see that Mr. Borkins uploaded all his videos for this section because he taught this section last year during hard lockdown to the Matrix. All right, so you'll be able to find it there. If you don't feel that you need that much revision, then work through the examples with me. And at the end of this lesson, if you're a little lost, then go back and look at the videos before you attempt to go through lesson 2. Okay, and like I have said in the documents accompanying the plan for this week, both classes, myself and Mr. Borkins' class, Ms. Garofoli's class, need to complete this by the end of this coming week. Please. Okay, so in other words, you have to have gone through the 2 videos, which is revision questions really, and you have to have gone through any of Mr. Borkins' videos if you need any catch-up on content. All right, let's start with example 1. Example A. All right, it is given that x is normally distributed with a mean of 25 and a variance of 3 squared. Find the probability that a random chosen value of x lies between 23 and 30. Alright, so it's always a good idea to draw your diagram first. So we draw our normal distribution. Alright, so we have our mean in the middle. Okay, so a good idea is to put your z and x values on the same diagram. So let's start with x, and I'll put the z below that. So they've given us a mean of 25. Okay, remember that this value here is your mean, and that's your variance. Okay, so the mean is 25, and the corresponding z mean will then be 0. And they want to know the probability that a random chosen value of x lies between 23 and 30. So in other words, we'll say that 23 is roughly there, and 30 would be that side of the mean. So effectively, we're looking for the area bound in between these values. Okay, so in between 23 and 30. That's the area that we're looking for. But we've got to first convert those x values into corresponding z values. Right, and to do that, I'm not going to do the calculation for all of them, but remember that to get the corresponding z value, you start with your x value that we're looking for, and you subtract the mean from it, and you divide by the standard deviation. Alright, so for the first one, the 23, we'll say 23 minus 25, x minus the mean, divided by the standard deviation, which in this case is 3. Remember the square root of the variance. All right, and then you do that to the 23 and to the 30, and you get the corresponding z scores in this case of negative 0.67. Don't forget the negative. Remember that in the z diagram, to the left of the mean are negative scores, and to the right are positive scores. Okay, and in 30, you get a corresponding value of 1.67. Okay, so all this really means, let me just erase that out the way. All this really means is that we can now translate the x values that we're looking for, because remember, we're looking for the probability of x lying between 23 and 30. Okay, but we need to translate that to z values. So this is then equal to the probability of x lying between negative 0.67 and 1.67. Alright, so you now need to realize that we're working with two parts of the area. Okay, we're working with this part to the left of the mean, okay, which is worked out by this value, and we're also working with the part to the right of the mean, which is the 1,67. So essentially, both of those values we're going to look up on the Z table, on the distribution table, and add the two values together. All right, so negative 0,67. Remember, you can disregard the negative when you're looking up in the table. Okay, but 0,67, you're looking for 0,6 down the left-hand side, the first column, and you're looking for 0,07 across the top, and then you find the value that they meet. Okay, so in this case, they meet at 0,2486. So that's the first value, 0,2486. And the 1,67 is 0,4525. And so we add that to get 0,7011. All right, so that's the probability that x lies between 23 and 30. All right, question B. When Bikanyo makes a phone call, the amount of time that the call takes has a normal distribution with mean 9.5 minutes and standard deviation 1.8 minutes. 94% of Bikanyo's phone calls take longer than P minutes. Find the value of P. All right, again, let's just realize that this is normally distributed. They haven't given you the normal distribution notation here, so it's worth it just to write that down first. So x is normally distributed, and the mean is 9.5, and the variance is 1.8 squared. Okay, and the standard deviation then is 1.8. All right, so they've told us that the probability of a call, so we let that equal x, that's the random variable, is longer than p, is 94% of the time. Okay, so 0.94. Now, knowing Bikanyo, she talks on the phone a long time, so that's why that's such a high percentage. All right, so here we have to utilize this formula again. Z is equal to x minus the mean over the standard deviation. Okay, but in order to get this Z value, it's an idea just to draw a diagram. In normal distribution, always draw a diagram to help you. Okay, so because P is less than 94% of the time, then we know that it's in the left-hand side here. Okay, so if we let P stand about there, all right, then we know that this whole area is 0.5. And so if we subtract the 0.94 from the 0.5, 0.5 from 0.94, we get 0.44. So this area here, in fact, is 0.44. Okay, and in this area over here is 0.06, but that's inconsequential. We're worried about this value at P. So in other words, the area from the mean to point P is 0.44. All right, so you look that up on your distribution table. You're looking for 0.44, and the closest we get is 0.4394. Okay, 0.4394 is the closest on the table. And in fact, if you look just to the right of 0.4394, we have 0.4406, which is equidistant from 0.44 as the 0.4394. So I would take the halfway point. Okay, so you're going to look at your 1.5. So we're working with the Z value here. So the Z value is 1.5 from the left. And then if we look at the top, we're looking at between 0.5 and 0.05 and 0.06. So we want the 0.055. All right, so in other words, we're going to have two fives here. Okay, then on the right-hand side, we have our variable P. That's our random variable X, which we're not sure what P is. From that, we subtract the mean, which is 9.5. And over that is the standard deviation of 1.8. And then you solve for P. You can do that in one step. Okay, and then that gives us a p-value of 6.701. Just pay careful attention to the instructions for rounding off. You're normally asked to round off to 4 decimal digits, all right? But just that's kind of standard if they don't tell you, but look carefully for that. Question C. Beatrice has chores to perform before getting to school at 7:30. The time to perform these chores is normally distributed with a mean of 34 minutes and a standard deviation of 6,205 minutes. Okay, before we even start, let's just draw the normal distribution. Alright, so X is normally distributed, and the mean is given as 34, and the standard deviation is 6,205 squared, which is then the variance. Alright, question 1. If Beatrice gets up at 6:50 a.m., what is the probability that she is late for school? Now, the question's a little bit vague in that we assume that getting to school is actually part of that time where the mean is 34 minutes, not just the chores as well. So in other words, the mean is her getting, from the time that she's got up, doing all her chores, getting ready, and going to school and getting to school is all included in that mean of 34 minutes. All right, so what we're actually looking for here, okay, so we're looking here for the probability of X being greater than 40, okay, because from 10 to 7 in the morning till 7:30 is 40 minutes. And we now need to work that out in its corresponding Z values. Okay, so how do we do that? Remember, we use this formula. Z equals X minus the mean over the standard deviation. So in this case, the Z value is equal to the X value, 40 minus the standard deviation, 34. Minus the mean, 34, over the standard deviation of 6,205. Okay, so to two decimal places, that gives us 0,97. Okay, you can use your Z score can be to two decimal places. That's absolutely fine. All right, so that means Z is greater than 0,97. Okay, so now, if you had to draw a diagram here of your normal distribution, remember that our mean is 0. So 0,97 is going to be in the right-hand side somewhere because it's positive. So we need to subtract, so that 0,97 is here. We need to subtract from 0,5 0,47, okay, because remember that this part here, that area is 0,5, and this part's area is 0,5. So if we subtract, and 0,97 represents the area all the way to there, okay, to the beginning. Okay, so effectively what's left is 0,03. Alright, but look on your Z table to get the exact values. So that means that the probability in this case is going to be equal to 0,5 minus, and then you look up 0,9 down the left-hand side, and then 0,07 along the top to get 0,3340. Don't round off these numbers until the end, okay? Don't round off your distribution table numbers. Just the Z score. When you worked out the Z score at this step, that's fine to round off, but not once you've taken the value from the distribution table. All right, subtract the 0,3340 from 0,5, and you get a total probability of 0,166. All right, question 2. And please remember, as you go through these lessons, if you do have any questions, please either let myself or Mrs. Groffley know if you're in Mrs. Groffley's class. I don't mind though if you ask me, because I have just done all the videos, so you're welcome to ask me if you need any assistance. Right, but question C2, at what time to the nearest minute should Beatrice get up to have a 99% of not being more than 3 minutes late for school? Okay, so in other words, now we're actually solving for our random variable x. Okay, so we can put that into normal distribution notation by saying x is greater than, and then we assign a variable. Okay, so little x now. We're looking for the time. That is, the time that she's got to get up in order for her to have a 99% probability of not being more than 3 minutes late for school. Okay, so, all right, and we're looking for values that are equal to 0.01. Okay, because remember, we're looking for 99% chance of not being more than 3 minutes late for school. So we're looking for that 1% chance that she would be more than 3 minutes late for school. Okay, and if you draw a diagram as well, then it makes sense why you have to use the 0.01. All right. Okay, so now what we're going to do is we have to find that 0.01. And in order to understand that, let me draw a diagram. Okay, so we know that the mean is here at 0.5. Alright, so our 0.01 will be up here. Because remember, then the 99% is this region here. Okay, so in that 99%, she won't be more than 3 minutes late for school. But in that last little bit is when she will be. Okay, so we've got to subtract that 0.01 from the 0.5 to get this area. Okay, this area. That's the area we're looking for. So in this case, that area is 0.49. If I can get the right color. Okay, 0.49. All right, because the 0.49 plus the 0.01 would bring us to 0.5, which is the right-hand side of the mean. Okay, so look for the area of 0.49 on your distribution table, and I'm looking in the 1, 2, 3, 4, 5th row down, and 1, 2, 3, 4 columns across. Okay, so 0.49 is somewhere between the 0.48983 and the 0.49010. So we can just take the halfway point between that. So that'll be, in fact, no, scratch that. The 49010 is much closer. Okay, so let's just leave it at that. So we use the 2.3 from the left and the 0.03 from the top to get a z-score of 2.33. Okay, so our z-score, excuse me, is 2.33, and that is equal to x, that's what we're solving for, minus the mean over the standard deviation of 6.205, and solve for x here, and we get x is 48.5 minutes. Okay, I've rounded that off to 1 decimal place because the question asked for the nearest minute. So 48 and a half minutes before 7:33, because remember, not more than, she can be 3 minutes late. So up till 7:33 is fine. Obviously, she doesn't go to Rodine, this particular Beatrice. But after 7:33 is not acceptable. Okay, so 48 and a half minutes before 7:33 is 6:44. So you must give it in time because they did ask for the minutes. Okay, so 6:44. Question D. In an AP examination, 10% of the students obtained more than 80 marks and 15% obtained less than 40 marks. If the marks were normally distributed, find the mean and the standard deviation. All right, so here we've got to find two different things, the mean and the standard deviation, but they've given us two different sets of data. Okay, so remember, I always like to write out the distribution if they haven't given it to us. So x is normally distributed, and we don't know the mean and we don't know the variance. Okay, so we're solving for those two things. The two bits of information they've given us is that the probability of scoring less than 40 is 15%. And they've also told us that the probability of scoring greater than 80 is 10%. All right, so using these two values now, we've got to find our corresponding z-scores. So let's draw a diagram. I'm going to draw a little mini diagram at the top here, so it's out of the way. Okay, so our mean is in the middle. And obviously, the kids that are getting less than 40 are going to be on the left of the mean. So that's going to be where our 0.15 is. And the kids that are getting greater than 80 are going to be, and that'll be negative 0.15. And the ones that are getting greater than 80 are going to be 0.1. Okay, sorry, not negative there because that represents the area. Remember, we'll get to the negatives when we get to the z-score. Okay, so for the corresponding z-scores, For the 0,15, we're going to subtract that from 0,5. Remember, this whole area is 0,5. So we're going to subtract the 0,15 to get this area, which is 0,35. Okay, so I'm going to put that in there. That's 0,35. And 0,35, we then look up on our distribution table, and the closest area is 0,3508. All right, and that gives us a corresponding z-score of 1,04. But remember, it's negative. Okay, so in other words, this value here is negative 1,04. All right, you must put the negative in because it's to the left of the mean. All right, if you don't, you're gonna get an incorrect answer. Okay, so negative 1,04 must equal 40, which is our x value, our random variable, minus the mean, which is what we're solving for, and that's over, let me just neaten that up, over our standard deviation. Okay, so you can simplify this a little bit into the mean minus 1,04 sigma is equal to 40, and make that equation 1. All right, so you'll see that if you're solving for mean and standard deviation, I always do it this way, where I put the mean and the sigma on the left, and I put the constant on the right, because then I like to solve by elimination. But if you solve by substitution, it's also fine. All right, let's look at the right-hand side. So the probability that x is greater than 80 is 0,1. So again, we're going to subtract 0,1 from 0,5, which will then give us 0,4. So the area in, I'm going to change color, in this region then is 0,4. Okay, so look for the area on the z-score table that is closest to 0,4. And the closest is 0,3997, which gives us a corresponding z-score of 1,28. All right, so 1,28. And this time it'll be positive because it's on the right of the mean. 1,28 is equal to 80 minus the mean, which you don't know, over the standard deviation. All right, and again, multiply this through in the same way. So I'm going to take the mean over and add that to 1,28 mean is equal to 80. Okay, and there's equation 2. And now we can just solve simultaneously. So very quickly, if we subtract one equation from the other, then we can eliminate. Okay, so I'm going to say equation 1 minus equation 2. So the mean minus the mean is 0. And then negative 1,04 minus 1,28 is negative 2,32 sigma is equal to 40 minus 80, which is negative 40. And therefore, sigma is equal to 17,24. Okay, so that's the standard deviation. The mean then is easy to work out. We just need to substitute that 17,24 into any of the expressions. Sorry, I've just seen, and I'm not going back to redo it, I've just seen that that should be a sigma. Okay, so just replace that with sigma. Sorry about that. Okay, and then the mean is 57,93. All right, question E. The weights of packets of noodles are normally distributed with a mean of 250 grams and a standard deviation of 6 grams. 1. Find the probability that a packet of noodles weighs between 242 grams and 260 grams. Okay, so firstly, let's just write down the normal distribution. All right, so X is normally distributed with a mean of 250 and a variance of 6 squared, or a standard deviation of 6. Right, so the probability that the packet of noodles weighs between 242 and 260 means that we're looking for the probability that X is between 242 and 260. Okay, now you've got to work out your corresponding Z values for the X values that are given. So that is equal to the probability of, we know Z is going to be in the middle here. And remember, the way that you work out these probabilities, you'll take, for the 242, you're going to say 242 minus the 250, which is the mean, and divide that by 6, and that gives us, and remember that because of your diagram, that shows you where it's negative and where it's positive. So if the mean's 250, then 242 has to be that side and 260 has to be that side, which means that that's your x values. Your corresponding z values are 0 for your mean, and negative 1,6. I'm just looking. Sorry, negative 1,33 must be negative because it's to the left of the mean, and 1,67 is the one to the right of the mean. Okay, so this is negative 1,33, and this one here is 1,67. All right, and then before we continue, if you just look at the diagram, we can see that the total area we're going to need to add. We're going to need to add that portion, which is represented by that value, and we're going to need to add that portion, which is represented by that value. Okay, so we know we've got to add. So once you know you're adding or subtracting from 0,5 or whatever it is, then you can disregard the negative that's in front of the z-score, and you go directly to your distribution table. Okay, so the distribution table for 1,33, and I'm just checking it myself, 1,33 is 0,4082, and then 1,67 is 0,4525. All right, and we add those together and we get 0,8607. All right, question 2 says that 10% of the packets are too light and cannot be sold. What is the minimum weight? Okay, so we're looking for our random variable now, which is we're going to represent as little x, but we know that 10% of them are too light. Okay, remember this point is showing us that the values that are less than a certain value, they're 10% are 10% of the total amount. Okay, so we've got to look basically at exactly how many or at least what is the mass of that particular grouping. Okay, that 10% that are too light. All right. So remember, if we draw our diagram, we have the mean in the middle. Okay, and that mean in and that mean, in terms of x is 250, and obviously in terms of z is 0. Okay, now we're looking at this 10%. Okay, so this 10% must be done here. That means that area there's 10%, but we need the area from the mean. So subtract the 10% from 0,5 and we get 0,4 as the area that we're looking for. Okay, so and remember, it's got to be negative because we're to the left of the median. Of the mean. So look for 0,4 on your distribution table, and we get 1,28. Okay, so we know that's then got to be negative 1,28. Okay, is equal to our value that we're looking for, x minus the mean 250 over the standard deviation, which is 6. Okay, and now we can solve for x. So x is 242,32 grams. Okay, so let's just interpret this for a minute. What this means is that we know the mean is 250 grams. That means that 10% of the entire group of packets of noodles are less than 242,32 grams. Okay, and those are the ones that are then too light. All right, question F, the last question for lesson 1. Okay, so the marks of 4,000 physical science students are normally distributed with a mean of 64% and a standard deviation of 11%. All right, so let's look at 1. Estimate how many students obtained a mark higher than 80%. Okay, so let's just define our normal distribution. We know that they've given us an important number here, that there's 4,000 physical science students in total. Okay, they didn't do that in some of the previous questions. So when they have given it to you, it means you're going to use it somewhere, and just write it down as an introductory thing before you even answer the questions, and always write down your normal distribution. All right, so random variable x is normally distributed with a mean of 64%. Don't put any units in your distribution. You just leave the numbers as they are. And the standard deviation of 11%, so that means we're putting in the variance, which is 11 squared, into our normal distribution. Okay, so we're looking at the probability that a student scored greater than 80% in the test. Okay, but now in order to do this, we obviously have to convert to the relevant z. Okay, so let's draw the diagram. And we know that the mean in the middle here is 64 when we're talking about x, and it's 0 when we're talking about z. But 80% obviously is to the right of the mean. So 80%, we're looking at this region here. All right? Okay, the corresponding z value that you need. Okay, so remember, you're going to take this 80 and you're going to subtract the mean, 64, and you're going to divide by 11, and that gives you a total of 1,45. All right, and that's a z-score, but it corresponds to the x value of 80. All right, secondly, because of the diagram and because of where I've put the highlighted region, we've got to subtract that area, this area, from 0,5, so that we get this area here between the mean and the x value of 80. Okay, so subtract that from 0,5, but we've got to also find the corresponding area on the table. Okay, so that means it's going to be equal to 0,5 minus, and now you look for your area with using your z-score of 1,45. So that gives us an area of 0,4265. Zero comma 0,735. And this is why it's important that you had to write down the number that they gave you, because they asked not the probability or the percentage, they asked exactly how many. Okay, so you've then just got to multiply your probability by 4,000 to get a value of 294 students. All right, obtained a mark higher than 80%. Question 2. Determine the mark that is exceeded by 60% of the students. All right, so in this case, we're looking for the A value, effectively. We know what we normally use in our probability. So we're looking for this A value, the probability of how many will get 60%, okay, or at least exceeded by the mark that's exceeded by 60% of the students. Right, so if we draw our distribution diagram, all right, so we've got our mean in the middle here with our 64%. And now they're saying determine the mark that is exceeded by 60%. In other words, what mark do 60% of the students get more than? So in other words, our value has to be to the left of the mean, okay, where this area is 0,1, that area is 0,4, and that area is 0,5. So that these in combination would give us the area of 60% of the marks exceeded, okay? All right, so in other words, in your distribution table, you're looking for the area closer to 0,1, which is 0,0987. Okay, and that gives you a corresponding z-score of 0,25, and it's negative. All right, don't forget that. So negative 0,25, and that is equal to our x value, in this case A, minus the mean, 64, over 11, and then solve for A, and we get 61,25%.